Let's transform a cubic equation next. So my f of x is the cubed root of x, and g of x is the cubed root of negative 8x. Remember that negatives are a separate transformation than numbers. So we will take the negative and the 8 separately. So looking at the negative, I notice that it is inside with x, and so that means that I am reflecting over the y-axis to affect my horizontal or my x values. So this is a reflect over y. Refer to your chart if you need to. And then the 8 is my second transformation. Again, it's happening multiplied by x, inside with x under the radical. So that's going to be horizontal. And remember that it's opposite. So if I see a number bigger than 1, it's actually a shrink by the reciprocal. So it's a shrink by 1/8. Let's go ahead and plot both the parent function and the transformed function. So let's pick out some f of x, x and y values from my basic parent function. I know that my first point is going to be at 0, 0. And I remember seeing that on my first page, but I can prove that to myself. If I plug in a 0 for x, the third root of x is 0. If I plug in an x value of 1, the third root of 1 is 1. So I can say that 1, 1 is another point. Now I want to pick the next x value that's going to be a perfect cube. So if I picked an x value of 8, I would get that the cubed root of 8 was 2. So for an x value of 8, I'm going to get a 2. Now let's go the other direction. Remember that this graph went from positive to negative infinity. So at negative 1, I will get a y value of negative 1. And at negative 8, I'm going to get a y value of negative 2. Let's go ahead and plot those points. So 0, 0, 1, 1, 8, 2, and then negative 1, negative 1, negative 8, negative 2. So my graph, just like we saw on the first page, is going to look something like this, kind of like a sideways cubic function. Again, that's because it is a cubed root. So it is going to look kind of sideways and opposite of a cubed function. Now let's do g of x. And I'll identify some x and y values. We didn't move up, down, left, or right, so that 0, 0 point will still be good. I can prove that to myself if I plug in a 0 here. Anything multiplied by 0 is 0. Third root of 0 is 0. The next point that I'm going to pick is a point at 1. And if I plug in a 1 here, 1 times 8 is 8, and it's actually a negative 8. Cubed root of negative 8 is going to be negative 2. If I plug in, let's see, the next one I want to do is going to be 8. And the reason for that is I know that if I have 8 times 8, that's 64, with a negative, negative 64, and I know that the cubed root of 64 is going to give me a negative 4. Cubed root of negative 64, I should say. I'm also going to have a couple of points that are opposite. At negative 1, I'll get positive 2, and at negative 8, I will get positive 4. So let's go ahead and plot those points. At 1, I'll be down at negative 2, and at 8, I will be down at negative 4. And then I have negative 1, positive 2, negative 8, positive 4. Let's talk domain and range. Remember that those are not going to change for a cubic function. We are always going to have domain and range of all real numbers.